Today's in-flight summary lesson is climbing and descending. Remember, the horizon is a primary reference and your eye should be on the horizon for the majority of the time. Let's start with the climbing demonstration. The acronym we use for a climb is LPAT or LPAT. L stands for lookout. Before initiating a climb, it's crucial to thoroughly scan the area for other aircraft. This means looking left, center, above, and right to ensure the airspace is clear. P is for power. Once you're sure the airspace is clear, increase the power. Consult your pilot's operating handbook, that is a POH, and your instructor to determine the best power setting for your aircraft during a climb. A stands for attitude. Gently move the control column rearward and adopt the climb attitude and nominated airspeed. Once you have the correct climb attitude, you may need to readjust the power again. T is for trim. With the climb attitude set and airspeed stabilized, trim the aircraft to maintain the correct airspeed, then balance with rudder. Now it's important to continuously monitor engine temperatures and pressures, often referred to as T's and P's. High power settings and reduced airflow during a climb can lead to overheating. If you notice the engine temperature rising too much, level off to increase airflow and if necessary, reduce the power. During the climb, a good lookout is vital. Due to the high nose attitude, it's challenging to see what's below the nose of the aircraft. Every 500 to 1,000 feet, gently lower the nose to check for other aircraft and to monitor engine temperatures and pressures. If all is clear, you can continue your climb. When it comes to climbing, we can choose from different types of climbs based on the situation. The three main types of climbs are the normal cruise climb, best rate of climb, also known as VY, and best angle of climb, also known as VX. Let's now simulate the three typical types of climb. I am now demonstrating the normal cruise climb, and it is usually 5 to 10 knots faster than the best rate of climb and is used during regular flight operations when the maximum climb rate isn't as critical. I am now demonstrating the best rate of climb, or VY, and it allows the aircraft to reach a nominated height in the least amount of time. The airspeed is usually 5 to 10 knots slower than the normal cruise climb, and the attitude or gap between the nose of the aircraft and the horizon is less than the normal cruise climb. I am now demonstrating the best angle of climb, or VX. This helps you gain the most height in the shortest horizontal distance. As you can see, the airspeed is often 5 to 10 knots slower than the best rate of climb, and the attitude and gap between the nose of the aircraft is less than the best rate of climb. Consult the pilot operating handbook for your aircraft type for the required speeds and power settings for all types of climbs and descents. Leveling off after a climb follows a similar sequence. However, this acronym and sequence is the only one that is different. We use the acronym LAPT or LAPT. L stands for lookout. Again, check for other aircraft by scanning your surroundings and the horizon. A is for attitude. Gently move the control column forward and return to the level attitude. P stands for power. Reduce the power to your cruise power setting. T stands for trim. Once level, trim the aircraft and then ensure the aircraft is balanced with rudder. Remember, always adjust the attitude first when leveling off after a climb to protect your airspeed before reducing power. Now I'll demonstrate how to descend from level flight. Again, we use the acronym LPAT or LPAT. L stands for lookout. Start by checking for other aircraft, scanning left, center, below, and right. P is for power. Reduce the power according to the PO8's recommended setting for a descent. A stands for attitude. Gently move the control column forward and adopt a descent attitude. T is for trim. After stabilizing your descent, trim the aircraft and keep the aircraft balanced with rudder. During a descent, keep a close eye on engine temperatures and pressures. With lower power settings and increased airflow, the engine can cool excessively. If you notice the engine getting too cold, level off and increase power to warm it up before resuming your descent. There are three main types of descent you should be aware of. They are the cruise descent, glide descent, and approach descent. For a cruise descent, you'll use some power and maintain the same cruise airspeed, typically descending at a rate of about 500 feet per minute. For a glide descent, no power is used. You'll control your descent rate and glide angle using attitude and airspeed. For an approach descent, which is used during landing, you'll likely use flaps, and if you have a retractable undercarriage, that will be extended. In this case, power is applied to overcome some of the drag and to keep the aircraft on the correct approach profile. Remember, during a descent, we can control our rate of descent with power and our airspeed with the attitude. To level off after descending, use the acronym LPAT once more. L is for lookout, to scan the area for other aircraft. P is for power, increase the power back to the cruise power setting. A is for attitude, move the control column gently rearward and return to the level attitude. And T is for trim, trim the aircraft once the airspeed is stabilised and then maintain balance with rudder. Throughout climbing and descending, your focus should remain on the horizon. However, don't forget to keep an eye on your instruments for accurate performance monitoring. Key instruments include your engine RPM, oil temperature, oil pressure, airspeed indicator, altimeter, vertical speed indicator, slip or balance indicator, and the artificial horizon. Consult the Pilot Operating Handbook for your aircraft type for the required speeds and power settings for all types of climbs and descents. During both climbing and descending, it's essential to monitor engine performance to prevent overheating during climbs and overcooling during descents. For example, during a descent, especially in high humidity or visible moisture conditions with a low power setting and high airspeed, this could cause the engine to cool too rapidly, potentially also leading to carburetor ice. In this instance, it would be wise to use a carburetor heat button if your aircraft has a manual carburetor heat. Finally, let's touch on the effect of flaps during these maneuvers. We'll start with a glide descent, where I'll select 2 stages of flaps. We now have 2 stages of flaps selected. Notice how the rate of descent increases for the same airspeed due to the extra drag the flaps generate, which also reduces our glide range. Now we'll demonstrate a climb with flaps. And in this climb, I'll select 1 stage of flaps. You'll notice now a rate of climb decreases, again, due to the extra drag created by the flaps. We hope you enjoyed the climbing and descending in-flight summary. Happy and safe flying, and see you next time on Go Fly Online.